Hello coders, welcome to my video. In this video, we'll study about how to create the dynamic memory using the heap section of our program. So what do you mean by dynamic memory is when your program start running, that memory is calculating and depending on that, the action is will be taken on that memory. So as we have seen, we have stack segment also in which the memory is calculated at the compile time only. But in the real time scenario, we don't have this thing sometimes in which we need much more memory at the runtime of a program. So in order to incorporate that, we use a API named malloc. Okay. So for example, I have malloc and then we have the size in bytes in this malloc. Okay, so for example, I am taking 8 bytes or I'll take 16 bytes. We can write it to multiply by 8 as well. Okay, and what this malloc will return? It will return a void pointer, for example, like this. Okay, so this 16 bytes of memory don't have any type. Okay, so if I need to check this memory, whether it is on the stack section or the heap section, what I will do, I'll just printf the address of this memory. So address of ptr is equal to percentage of p, and here what will I write? I will write ptr. So if I compile it, what type of memory it contain? So gcc. Okay, then we have this address 0 cross 55. So this is the heap section of the memory. So how will we check the memory segments? So we can take these maps. Okay, so here you can see this section lies in the heap area. Okay, so if I need to check the stack section, so this memory area is designated for the stack section. So we are getting the memory in the section of heap. Okay, so few things about malloc. For example, if I need to write something in that, so if I write star ptr is equal to, I will put 1000 over here, and then I try to print data is equal to percentage d, and here we have star ptr. Okay, let's see what's the data. Okay, so you are getting the error first. Invalid use of void statement. So we don't define any type to this. So what I will do, I will take a int pointer here in spite of void. So int star of ptr. Now we are giving this 1000 to this, and now I'm printing here. So let's see what will happen now. Okay, so you are getting, okay, it's data not great. So, so here it's automatically converting it into int and not giving us error in this compiler. So if I take warning as error, still I'm not getting in this compiler, but this will have the type here. So we have to typecast this memory because by default this malloc will give you white and we have to typecast it into int and then we can put the data in here. I want to tell you a few things about malloc. For example, if I write some wrong data here, will it work? See, you are getting a segmentation fault immediately. So this data, we need to have some check while providing it to malloc. Okay. So we can give, for example, I'll give lot of memory at runtime and it got compiled now. So there is no problem in compilation, but when I run it, it will give me segmentation fault. Okay. So this memory is calculated at runtime, not at the compile time. So you won't find any error while you are compiling this. But once you run this program, you will get this segmentation fault, and it's very difficult to find this segmentation fault without some external tools. Okay. So what if I have similarly 16 bytes of data and I will take this data again and now I want to calculate the total memory that is allocated by this malloc. So it's not 16 bytes. So we need to check how many bytes is allocated. So what I will do, I will take actual memory is equal to percentage D. Okay, and then I'll use an API implicit declaration of function malloc. Okay, so I think it need a header file malloc.h. Now it is going for size underscore key that is long int, and if I put that LD, then I think it would be solved and you will get the actual memory as 24 bytes, not the 16 bytes. This is due to the padding in the memory. As we already know that heap grows upward and stack grows downward. So let's prove it. So what I will do, I'll take one more malloc, okay, and I'll make it ptr1 and similarly I'll just copy it up and just replace ptr with ptr1 here also 1 and here 1 as well and here I'll put ptr1. Okay, so now I'll copy this as well and do it 101001. Okay, so as we have created the memory in heap, we need to free it as well. Okay, so at last what I will do, I'll free both these memories. So we'll use an API free, and the first one is PTR, and the second one is PTR1. Both this memory will be freed once it is being used. So let's save it and see the address of these memories. So if you see here, the PTR, which is allocated first, have address A0, and here PTR1 is approximately greater than this. So it means the memory has been incremented. Okay. And here the actual memory of both the things are same, but here I'm getting the data 0 at PTR1. So why it is like this? So maybe, oh, I think I use PTR1 here. Now it is fine. So by seeing this, we can clearly see that the heap memory is growing. Okay. So one more thing we'll do, what I will do here, I'll dd here and I will feed just before that allocate ptr1. Okay. So if I do like this and I compile it and I run it, so what I see in here, that these two memories are approximately, or it is same, exactly same. Okay. So it proves that the first memory which we allocate here got free, and the next memory which we allocate is given the same memory which we allocate earlier because it's been free. So by using this free API, we can free the previous memory and reallocate that memory to some other variable as well. So this way we can do. Thanks for watching this video. See you in the next video.